Now what this will be now? Here you take a ring. Ring you keep it in what? YZ axis. Okay. So in which axis we are keeping? Here this will be here. Right? So Z axis is not. So just for your reference I should. Okay. So this is YZ. So along this one I take it as what? X axis. Now what is that? At point P, due to this is a ring, right? So uniformly distributed charge ring. Okay. A ring with uniform charge distribution. So what is lambda? Lambda is Q by L. But L we know that it is 2 pi A. I will take it as what mark? Here this radius as A. You can take it as capital R also, that is depending on you. I have taken it as A, so I will keep. Correct? So now I have to find out the electric field at point P due to this point charge distribution, which is at a distance x. So for this point P, the x is constant. Is that clear? The radius of the circular ring is constant. That also we know. Since it is a charge distribution, I will consider what? A small element dl here. What is the charge in that small element? It is dq. So lambda will be equal to dq by dl. So dq is lambda times dl I will do. Correct? So due to this small element dl, I need to find out what? The electric field at the point. Correct? So which will be what? In this direction. Correct? You have to keep a unit positive charge. It will be like this. Let me take it as what? Theta. What is this distance? R. Now, again I will go back and consider what? Another one small element dl exactly opposite. Correct? Where the charge will be what? dq. Which makes an angle theta at the point P. Correct? So, if I draw, what it will be? This is my electric. Correct? Due to the small element, so it is dE and dE. So here also what it is? Since it makes an equal. This A is same. X also same. So R will be same. That means theta remains equal. Any doubt? Tell me. From the diagram, first we will sort it out. Cos theta is what? R by A. Correct? Sorry. R by A, how we say? What am I writing? Cos theta is what? Ma? Cos theta is adjacent by R. Here x by R. Very nice. R is what? Pythagoras theorem, a square plus x square, right? Under root a square plus x square. Next what I need? Since this is theta and this is theta, this side also what it will become? A theta and theta. Correct? So I can resolve this into two components. One is dE cos theta. Another one is dE sin theta. Here also again this one is what? dE cos theta. This is dE sin theta. Sin components, sin theta components cancel. Cos theta components adds up. So D net I want to find it out. DE net will be equal to DE cos theta we need to find. Correct? It is due to this cos theta component. So what is DE ma? K dq by r square into cos theta, which I can write it as K lambda dl cos theta by r square. Correct? So cos theta is what? It is K lambda dl cos theta. I can write it as x by r cube. Correct? Now K is constant, lambda is constant, x is constant, r for the given one is also constant. So K lambda x by r cube, if I take it outside, it is dl. Okay? Any doubt? Differentiation of dl is what? It is L. Correct? But from length, from where to where, considering the entire circumference, right? So 0 to 2 pi r. If you start at one point, the entire 360 you will complete. So that gives you what? Circumference. So k lambda x by r cube, upper limit minus lower limit. So what it will be? K lambda x into 2 pi r by r cube. Okay, this is integration I have done. So it will be E net. So E net will be equal to this one. See here, lambda into 2 pi r is what? Q equal to lambda into 2 pi r. So this will be nothing but what? KQX by R cube. Clear, ma? In fact, see in the flow I just substituted dq value. I shouldn't have substituted dq value. Directly I could have. Okay. That time also KQX by this only use. Don't keep it like this only. You need to further solve it. What it is? R value depends on R value. We don't know. We cannot go and calculate. A is given, X is given for the point. So KQX by A square plus X square to the power 3 by 2. Correct? So this is the E net along the axial line. Any doubt? Tell me. Now, at x equal to 0, what is the value of E net, ma? E net is 0, right? Second, maximum value of E. Where you will get it? For that you have to do what? dE by dx has to be 0. Correct? So you need to find out dE by dx. Just do that. So dE d by dx of kqx by a square plus x square to the power 3 by 2. Correct? This you need to differentiate it. Do that and tell me in the next class. If you are not able to do it, I will do it. When you do it, first order derivative, if you equate it to 0, what you will get? X value, you will get it as r by 2. So substitute that x value in this equation. So E maximum value you will get it as 2kq by 3 root 3 r square. I am giving it as homework. So you just try this differentiation. In case if you are not able to do it, I will do it in the next class. But maximum value you should know that it will be plus or minus r2 you will get it, r by root. And the maximum value is this. So I have to draw the graph, right? So if I take x along the x-axis, that is the distance, and E along the y-axis. So how it will be? This is the center of the ring, right? So from this, the E value, as x increases, E also increases, and it reaches maximum value at what? When x equal to r by root. Then it decreases, okay? Similarly, this side if you go, x increases, minus x increases, this one what? E also increases in the next egg, negative x-axis. So, again at x equal to r by minus r by root 2, it is maximum value. And then it decreases. Is that clear? This is the graph. For a ring, when you talk about it, E is in both the ways, right? Any doubt? Tell me. We need to check the disk also. That I will do it in the next class. Okay. What you can do? You can do this sum. This I have done already. No need. Okay. Next class we will do the sums.